Hi everyone, this is Algebra 2, and we'll be doing Lesson 1-2. In 1-2, we're going to be dealing with what's called inequalities a lot. And what we need to do is, for this first example, is translate a sentence into a one-step inequality. But before we jump into number 1, we need to kind of refresh our memory on the vocabulary of an inequality. So starting back even in 6th grade, you should have seen the less than sign. I think back then you might have called it a crocodile, but less than, and I always remember this is less than because it looks like an L, a slanted L. So this is going to be less than. And hopefully you remember that this sign going in the other direction is greater than. And this sign is less than or equal to, but in translating, you're going to see words like no more than, and also at most. And all these things are just memorization. You're also going to have what was previously called greater than or equal to, but you're going to see words like no less than, or at least. And this is stuff that you just have to memorize. Before, we would have saw examples like this, and this is kind of what we're getting into still. 4 is less than x. Kind of what that's going to translate to is 4 is a key word, less than x. And the reason why I'm highlighting the word is, I'm highlighting the word is because is in our previous examples of, I believe it was 1-1a or 1-1b, within 1-1, we were translating word sentences into equations or expressions. And we said usually is represents the equal sign, but is here is representing an inequality. And to kind of show you the difference, 4 less than x would be x minus 4. And that's kind of attaching to an example that we did in 1-1. Notice there's no is on that bottom example, but there's the word is at the above example. And that's how you would be able to distinguish between the two when translating. Usually in the sentence or in the directions it might say to even translate the inequality. And that will kind of give you a key into what you're doing. So let's look at number 1. It says translating a sentence into a one-step inequality, and we have our sentence right here. It says a number w increased by 4 less than negative 25. So we have a number w increased, that means a plus, addition, by 4 is, I see the word is, which is now telling me inequality, is less than negative 25. Is less than negative 25. And now I have translated my sentence into a one-step inequality. And if we wanted to solve that, we can, but we'll do that later. Try the one on the right-hand side. Writing an inequality for real-world solutions, write inequalities represent the situations below. Okay, well, let's read the situation. To get the 10% discount, a shopper must spend no less than $100. Use D to represent the spending in dollars of a shopper who gets the discount. So to get this discount, we either have to spend $100 or we have to spend more than $100. So to get the discount, which is D, the spending in dollars, we either have to spend $100, the equal sign, or we have to spend more than. So we either have to spend more than or equal to $100 to get that 10% discount. And there you go. That's how you do that one. Let's try the one below it here. Hans exercises at least 30 minutes per day. Use T to represent Hans' amount of exercise in minutes per day. So we know that we're going to have T here. And I know that he's going to exercise at least 30 minutes. So at least 30 minutes. Actually, let me back up here. If he's going to spend at least 30 minutes, you know that he can spend just exactly 30 minutes or spend more than 30 minutes exercising. So again, Hans can either spend 30 minutes exactly or Hans can spend more than 30 minutes. And that's where we get the at least from, spending at least 30 minutes. Go ahead and try the one on the right-hand side. Number 3, writing an inequality given a graph on the number line. So there's a couple things that we need to have a prerequisite for. And for one, this is what's labeled as a boundary point. That's more just head knowledge. It's a boundary point. And then also, notice there's an open circle. Now, when we have an open circle, that's going to be less than or greater than. And then when we have a closed circle, I'm just going to write the word closed. That's going to be less than or equal to, and then greater than or equal to. And again, you've 100% have seen this even back in middle school, and hopefully even in Algebra 1. But if you haven't, then pay attention. This is hopefully a good refresher. What we're saying here is that any number that's shaded here, going to the left, shaded here, is less than the boundary point of -3. So no matter what this is saying is I basically want to create a statement that's true. Now, if I chose any number that's less than 3, that statement would be true. So let's test it. If I just chose randomly -10, is -10 less than -3? It is. It is. So that makes that statement true. Let's try the one on the right-hand side together as well. I have x, because it's saying use the variable of x. I have x, and then I have my boundary point right here. So it's a -2. And I need to figure out if this is greater than, less than, greater than or equal to, or less than or equal to. I need to figure that out. Well, automatically I see a closed circle, so I know that I'm going to have my equals to bar down here. But then I need to figure out if this is the less than sign or greater than sign. Well, a little trick here is if my variable is on the left-hand side of an equation, or excuse me, an inequality, or on the left-hand side just in general, my greater than sign or less than sign is always dependent on which way my arrow is going. So notice that this arrow is going like that, and that's the same exact sign as my inequality sign, which let's just fit that in here. There you go. X is greater than or less than, is greater than or equal to -2, meaning it can also, x can also be -2, so -2 is greater than or equal to -2 because -2 equals -2. Or I can say, to make this true, 0 is greater than -2. Well, that's true as well. So again, any number that lies along that shaded area makes this statement true. And again, the trick is if my variable is on the left-hand side, then I will be able to figure out the angle or the side the inequality is choosing based on my arrow. So if we went on the left-hand side, for example, 3, this is going this way, right? Left. Notice that my inequality was the exact same as the arrow. But again, that only works when my variable is on the left-hand side. So it's just a little trick for you. Let's move on to number 4. Graphing a compound inequality on the number line. So all we need to do now is take the inequalities that are given and then graph them. So let's look at the one on the left. We have x is less than 5 or x is greater than or equal to 8. So let's just focus on this one. And I'm going to say this is 0, 2, 4, 6, 8, 10. Again, I made these numbers up on the number line. And we're saying x is less than 5. So is this going to be an open or closed circle? again, this is why memorization is key. This is going to be an opened circle. An open circle. Oh, it's not right there. Forgive me. That is 3. That's going to be right here. 5. And then remember, any number that's less than 5 is going to make that statement true. Now I have x is greater than or equal to 8. It's going to be a closed circle because it's greater than or equal to, or and equal to. And it's any number that's greater than or equal to 8. There we go. Try the one on the right-hand side. Additive property of inequality with integers. This is from the lesson 1-1a, but instead of an equal sign, we have an inequality. We're going to do the exact same steps as we did before for solving for a variable, but there are some situations that will change the sign of the inequality, and we'll get there in a little bit. Solve the inequality for the variable. Simplify your answer as much as possible. So we want to solve for w there. We need to get w by itself. So almost treat this inequality sign like it's an equal sign. It's not, but you could treat it like it is 1. So we're going to add 11 to both sides. You get -1 is less than or equal to w. Now notice my variable is on the right-hand side. You can also have the answer or w, and notice that the crocodile mouth is facing the w. So I would just make it facing the w again, -1. And now my variable is on the left-hand side, and because it's on the left-hand side now, if I had to graph this and draw the arrow, I know which way the arrow is facing because I have my variable on the left-hand side. So a little trick to get there, and then you want to try the one on the right-hand side. 6, additive property of inequality with sign fractions. So again, how to solve this should be reminiscent of 1-1. I need to -3/5 and then -3/5. So we get y is greater than -1/3 -3/5. I want to find a common denominator, which is 15. So I need to multiply by 5, multiply by 5, multiply by 3, and multiply by 3. And hopefully you remember from this is from 1-1. So now I have y is greater than -5/15 -9/15. And now my denominators are the same, so we just do our normal mathematics here, and we get -5 minus 9 is -14, and we keep the denominator. And there you have it. Try the one on the right-hand side. Number 7, multiplicative property of inequality with integers. Solve the inequality for the variable. Simplify your answer as much as possible. Okay, so this is where we get into something a little bit different. We're still solving the same way that we did in the 1-1 section of just solving for a variable, but there's a key point here I want to make. So let's make a note here, is that when multiplying or dividing by a negative number, let me clean that up, by a negative, what you want to do is flip the inequality sign. Flip the inequality sign. So let's see an example of that right now. On number 7, I have -3x is greater than 15, and I want to just get the variable of x by itself. So what do I need to do? Well, I need to divide by negative 3. Divide by negative 3. So now I just get x, but it says when multiplying or dividing by a negative, we need to flip the inequality sign. So no longer is it greater than, we have to flip the sign and make it less than negative 5. So we need to flip. Notice the sign went from greater than to less than. Try the one on the right-hand side. Multiplicative property of inequality with signed fractions. So same thing here, we're dealing with multiplication. So whenever I'm dealing with multiplication and division, I need to be on the lookout for negatives. Again, I need to be lookout for negatives. So I need to get v by itself. We want to multiply by the reciprocal of 4 over 5, which is 5 over 4. Whatever I do to the right-hand side, I must do to the left. 5 over 4. These all go, right? We're just left with v. This is over 1. 2 goes into 4 twice. 2 goes into 10. So we get negative 25 over 2. And remember, we multiplied by a negative number, so I need to flip the signs. Now, if I had to graph this, I would want my variable on the left-hand side just so it would make it easier for me to graph. So, or we can have v, and I need to make sure my crocodile is facing the v, because that's what we have here right above it, negative 25 over 2. And there's your answer. Try the one on the right-hand side. Identifying solutions to a two-step linear inequality in one variable. So let's see what we have here. It says for each value of x, determine whether it is a solution to 5 plus 2x is less than or equal to 1. So basically, we're told what the variable of x is equal to on the left-hand side. And basically we want to find out if each one of those numbers, when I plug it in, if it's a solution or not. So let's try that. We have negative 2 for our first one. So we have 5 plus 2, and we're saying x is negative 2, is less than or equal to 1. That gives us 5 plus negative 4 is less than or equal to 1, which is 1 is less than or equal to 1. And is that a solution? Is that true? Well, yes, 1 is equal to 1, hence why we have the bar under here. So this is a solution. What about this way of doing things? Let's do 5 plus 2x is less than or equal to 1. Why don't we just try to solve and get an equation for x? So let's test this. Let's try it out. Let's minus 5 from both sides. You get 2x is less than or equal to negative 4. Divide by 2. I get x is less than or equal to negative 2. Notice that you do not flip the signs because I divided by a positive. If I were dividing by a negative, then I would need to flip the sign. So now with this method here, all I need to do is, let's try negative 7. Is negative 7 less than or equal to negative 2? It is. So that's true. Let's try positive 7. Is positive 7 less than or equal to negative 2? No, it's not. It's not. 7 is greater than negative 2. And then what about 6? Is 6 less than or equal to negative 2? Nope, so that's not a solution either. So there's two ways of tackling this. One is what we did on the left-hand side here, of just using our example at the top and just plugging in x. So you can do that for every single one. So for that one, we used negative 2 and we plugged it in for x. Then you would try negative 7 there and then solve, and et cetera, et cetera. Or you could just solve for x and get x isolated by itself like we have here. and then just test out each one by replacing that x with the number on the left-hand side. Hopefully that makes sense, and try the one on the right-hand side on your own. Solving a two-step linear inequality with whole numbers. Solve the inequality for the variable, simplify your answer as much as possible. So we're doing the same thing here. We want to isolate our variable by itself. Let's go ahead and add 11 to both sides. I get 2u is less than or equal to 30. Divide by 2. We get u is less than 15. And the reason why I'm going fast, everyone, is because we've done this before. There's just an inequality sign attached to it. Try the one on the right-hand side. Number 11, solving a two-step linear inequality, problem type 1. So we're doing the exact same thing, everyone. Want to isolate the variable. 5x is less than negative 10. Divide by 5. I'm dividing by a positive, so I do not need to flip the sign. X is less than negative 2. Try the one on the right-hand side. Number 12, solving a two-step linear inequality, problem type 2. We're doing the exact same thing. Let's add 24 here. Add 24. Negative 5u is greater than 20. I'm dividing by a negative, and because I'm dividing by a negative, I need to flip the sign. So instead of u greater than, it's u less than negative 4. Try the one on the right-hand side. Number 13, solving a linear inequality with multiple occurrences of the variable. We've seen this before where variables on both sides from 1-1. So we could tackle it a few different ways. I'm going to just start with the 5u over here. I'm going to add the 5u. Now, could you have minus 2u from both sides? You could have. So it's dependent on what you want to start with. You'll still come to the same answer. Those cancel. Negative 17 is less than 7u plus 11. Let's minus 11 from both sides. That's negative 28 is less than 7u. Let's divide by a positive 7. So we do not need to flip the sign because it's a positive. I have negative 4 is less than u, or u is greater than negative 4. They're both the same thing. And this bottom one right here just makes it easier to graph if I had to, if the problem required me to do that. Try the one on the right-hand side. Solving a linear equality with multiple occurrences of the variable, problem type 2. So I see parentheses, and that automatically kind of points me towards the property of distribution. So we need to distribute that negative 4 to the 2, and then the negative 4 to the negative 3y. So let's do that. We have 5y minus 29 less than or equal to negative 4 times 2 is negative 8. Negative 4 minus 3y is a positive 12y. It's positive because it's a negative times a negative equals a positive. Again, that was one of those things that some struggle with, which is why we put it in our notes from 1-1. And now this looks very similar to the problem we just did. So we could start with the 5y or the 12y. I'm just going to go ahead and do 12y from both sides. That goes 5 minus 12y is negative 7y minus 29 is less than or equal to negative 8. I'm going to add 29 to both sides. Negative 7y is less than or equal to negative 8 plus 29 is 21. Dividing by a negative 7. So what do we need to do when we divide by a negative? We need to flip the sign. You should be thinking flip the sign. Negative 3. We need to flip. Try the one on the right-hand side. Translating a sentence into multi-step inequality. So this might seem difficult, but it's very similar to what we did, I believe, in problem number 1 of this lesson. It says the sum of a number times 10 and 21 is at most 23, and we're going to use the variable of w. So as the sum, that's addition, of a number, and they're saying that's going to be w, times 10 and 21 is at most 23. So it's saying the sum of w and 10, right? So we get 10 times w plus 21 is less than or equal to 23. Again, this is saying the sum of a number, which was w, times 10, which is what we have, right? We could do w and then a 10, but 10 times w and 21 plus 21. When you see this and here and it says sum on the left-hand side, that means you're taking that w times 10 plus 21. I can also write it this way. W times 10 plus 21 is less than 23. These two are the same exact thing. So if it helps just doing the bottom one, you could do it that route. But again, it's implied that that w and 10 are already being multiplied by the top answer. Try the one on the right-hand side. So solving a word problem using a two-step linear inequality. So the fish tank has 13 liters of water in it. She plans to add 4 liters per minute until the tank has at least 41 liters. What are the possible numbers of minutes? Is it Kesha or Keisha? Could add water, use t for the number of minutes, write your answer as an inequality, solve for t. So I know my variable is going to be t, but let's kind of pick out what we have here. So the fish tank has 13 liters of water in it. Okay, so it's already filled up with 13 liters. She plans to add, plus sign, 4 liters per multiplication minute. T, right? T. The tank has at least 41 liters. So that's all the information we have, and that's all the information we need. So let's translate it. The tank has 13 liters of water in it. She plans to add 4 liters per minute, right? 4 times t, because it said the time was t down there at the bottom. And then we have, where is it at here? At least 41 liters. What are the possible numbers of minutes she would need or to add water to the fish tank? So let's solve this now. I'm going to use red just to kind of make things a little bit more clear. Minus 13, we get 4t greater than or equal to 28, divide by 4. And since I'm dividing by a positive, I do not need to flip the sign. 7. 7 what though? 7 minutes. So it's going to take either 7 minutes to fill it up, or it's going to take more than that. So there we go. Try the one on the right-hand side on your own. Solving a decimal word problem using a two-step linear inequality. So it says, for her phone service, Carmen pays a monthly fee of $23, and she pays an additional 4 cents per minute of use. The least she can or has been charged in a month is $66.36. What are the possible numbers of minutes she has used her phone in a month? Use m for the number of minutes and solve your inequality for m. So as always, we're given a lot of things here, but we kind of need to pull out only what we need. So let's read this again. For her phone service, Carmen pays a monthly fee of $23. So that's kind of what she already pays off the bat. And she pays an additional, even has the word addition in it, right? Additional 4 cents per multiplication minute. The least she has been charged in a month is $66.36. What are the possible numbers of minutes she has used her phone in a month? So again, we have she pays $23. She pays an additional plus sign 4 minutes, or excuse me, 4 cents per minute. M, it's telling us to use M. And then the least she has been charged, keyword the least, she has been charged, the least. That's greater than or equal to. And then $66.36. And we need to solve this here. So it's minus 23 from both sides. I get 0.04 M greater than, and that's going to be $43.36. Divide by 0.04. You get M is greater than or equal to 1,084 minutes. Try the one on the right-hand side. And that's going to be the conclusion of lesson 1-2. Make sure you're studying the inequalities, when to flip an inequality, and kind of what the vocabulary terms are so that you know how to translate an inequality. Take care, everyone.